If you want to learn how to upload AFE firmware or any other firmware to a device based on the ESP microcontrollers family, this video will be about that. What do you need to upload AFE firmware or any other custom firmware to your hardware? You have to have hardware with ESP8266 or ESP8285 or ESP32 microcontroller on board. Secondly, you need to have USB TTL converter. This is a device like this one. On one side it has a typical USB connector, and on the other there are few pins used to transmit and receive data to and from ESP microcontroller. It basically enables data transfer between PC and hardware with ESP. On your computer you will see it as a typical COM port. There are several versions of USB TTL converters. This one uses CP2102 microchip. To upload firmware you can use converters built on other microchips like CH340 or PL2303 if I remember it correctly. However, I've been using this one, CP2102, for the last 4 years. This is 4 years old and I can truly honestly recommend it. It costs like $3, 3 euros, almost nothing. Maybe I will add a link to such hardware below this video, so if you don't have it you can find it quickly. What else? You will need cables like those to connect the converter with your hardware. If you have, it will be good if you have a USB extension cable. It's not a must, but connecting this converter directly to PC and with connected hardware is basically inconvenient. You have to have software to upload AFE firmware to a hardware. There are many different solutions for that purpose. I will suggest quite simple for firmware uploading called Tasmotizer. Tasmotizer is dedicated to Tasmota firmware, but it can be used for other firmwares as well. I highly recommend that software. It's simple, it's easy, it does the job well. If you like it, consider donating a developer who made it. It's a pretty nice piece of software. And last but not least, you need of course AFE firmware. How does the process of uploading AFE firmware to a device look like? The upload process, or using other words, flashing process, is relatively easy. You connect a device with ESP microcontroller to a computer through USB TTL converter. You put the device into a flashing mode, then you kick off firmware upload process using Tasmotizer software. After a minute or two, uploading finishes and you have to reboot the device by disconnecting it from the power supply and connecting it back. It sounds simple, it actually becomes simple after uploading firmware to, let's say, 10 devices. I guarantee that after uploading firmware to 10 devices you will become a subject matter expert. It will be a piece of cake for you. The first time is always somehow difficult. Okay, let's start from the very beginning. Connection. First, you need to connect ESP with the USB TTL converter. ESP has two pinouts marked as TX and RX. TX is used to send data and RX to receive data. The TX is known as GPO1 and in the case of RX is labeled as GPO3. The same label, so RX TX, you will find in the USB TTL converter. It's somewhere here. And now the whole trick is you have to connect TX from your device with RX in the converter and RX in your device with TX in your converter. It's like mixing the cables, TX with RX, RX with TX. It is related to how this data exchange protocol works. TX is sending data, as I mentioned, RX is receiving data. One channel, one cable is sending data and the other one is receiving data. What will happen if you connect cables incorrectly? For example, you will connect hardwares and converters TX together. Honestly, nothing will happen despite the fact that you won't be able to upload the firmware. The device will not break or be damaged. I have uploaded firmware many times, and I've not been always checking if I connected TX and RX cables correctly, but please do it right. Please do it always right. Check if TX is connected with RX and RX with TX. You will avoid problems like why it's not uploading, why it doesn't work. So limit your stress level by correct connection of those pins. Okay, next step is to connect the power supply. And here this is a very important that you do it right. In the converter, you will need to find pins labeled as 3.3 volts and GND or G. You need to connect pin 3.3 volts in your converter with 3.3 pins in your ESP-based device. Exactly in the same way you have to do it with GND, so GND or G depending on how it's labeled in your converter. You have to connect to G in ESP. In very simple words, plus with plus and minus with minus. What is very important, some converters have two power outputs, 3.3 volts and 5 volts. For example, this one. You must connect 3.3 volts with to the ESP, not 5 volts. If you connect 5 volts, there is quite a chance that you will damage your hardware. The same will happen, or the same may happen, if you connect 3 volts from the converter to the minus, so to the GND ground in your ESP hardware. Please pay attention here, you have to connect 3.3 volts to ESP, not 5 volts. And maybe a super important remark, you cannot have any other power supply connected to the device while flashing it. Never ever connect high voltage like 110 or 230 volts to your hardware. Remember, you have only those 4 cables connected to your device while uploading the firmware, so RX, TX, 3.3 volts and GND. In this video I won't help you to locate where are those TX, RX and power inputs in your hardware. Each hardware is different and you have to identify what is where by yourself. In such Sonoff Basic, all pins are over here. In 4-channel Sonoff, they are in that place. In Shelly One, you see them on the right side of this blue box. If you have device like Wemos or for example Node MCU like this one, connection is super easy as actually such hardware already has built-in USB TTL converter. You can directly connect it to your PC by USB cable. There are lots of hints on the internet on where to locate required pins to upload custom firmware. If you can't find them, drop a message at forumsmartnet.com, the link should be here. For sure someone will help you, I'm sure about that. Okay, let me go to my computer. You have to download the Tasmatizer software. The link to it will be below this video. You have two options to download, 64 bits or 32 bits version of Tasmatizer. If you don't know which one to choose, download the 64 bits, so the Tasmatizer 1.2. If it is not the correct one for your Windows, don't worry about it. You will see a message that it's incompatible with your Windows. Then of course download the second version and run it. It will be fine. The next step is to download AFE firmware, link over here. There is AFE firmware download section on the AFE firmware website. It includes all versions of AFE firmware. I described what are the AFE firmware versions in the previous video. The link to it is over here again. I'm going to download the basic version of AFE firmware, so-called T0. After pressing the link, I am redirected to a site with the latest version. Now I'm hitting the download button. The downloaded file is an archive, a compressed file. After opening it, I need to select version I am interested in. First, by selecting the language version, there is a Polish or English available. In the next step, I have to choose the API version. If you use Domotic as your home automation system, choose the Domotic version, of course. If it is Home Assistant, select Home Assistant. If you use something else, for example, OpenHub, then go for the standard version. I will select the Domotic version for the purpose of this instruction. In the next step, I have to select the type of ESP microchip. It could be ESP8266, ESP8285 or 32, or one of the versions for commercial products for which I have prepared a dedicated already pre-configured version. It's available for Sonos or Shelly One at the moment of recording this video. I'll choose the ESP8266 version because I'm going to upload the firmware to my custom device like this one I've just shown, which is based on ESP8266 microcontroller. Okay. In the last folder where the firmware file is located, there might be actually few files, such as a 1 megabyte or 4 megabyte version. They are dedicated to ESP with 1 megabyte or 4 megabytes. Size is highlighted within the name of the firmware's file. You have to decide which version to download by yourself depending on the specific hardware you own. Some versions of AFE firmware have a word debug within the file name. Those versions basically enable debugging the software while it is in the operating mode. Okay, I'm choosing to upload 4 megabytes version and I move the file to my desktop. Now let's start uploading the firmware. In order to upload the firmware, you have to put the device into the flashing mode. To do so, you have to connect pin labeled as GPIO0 in your ESP-based device with minus, so with G or GND marked pin in your ESP device. Let me show it. In my device, if I press this button, then GPIO0 will be connected to GND pin. This is like how that particular device is designed. So I'm pressing that button and while keeping it pressed, important, I'm connecting the USB TTL converter to USB port on my computer. Once the converter is connected to the USB socket, I'm releasing the button on my device. At this point, the device is in the flashing mode. Okay. I am back on the desktop and I am starting Tasmatizer application. What I need to do is to select the COM port associated with my USB TTL converter. If you don't know which COM is that, then let me show you how you can find it. I am disconnecting the adapter from my PC again. So without a converter connected to my computer, I'm checking what COM ports are visible in Tasmatizer. I see just those two. Then I connect back converter. Please remember about the GPIO0. It has to be connected to ground, so to do GND. So I'm connecting back. Then in Tasmatizer, I press the refresh button on the refresh button and look for a new COM ports listed over here. The new one is the COM port corresponding to my USB TTL converter. So this is COM number 3 in my case. Okay, so now after selecting COM port, I choose a firmware to upload to my device by pressing a button labeled as Open. Actually, from now I'm ready to upload the firmware by pressing the button down here called Tasmatize. But before I will press it, I want to highlight what are a few of the available options in this software. if you upload software to a commercial product, for example, Sonoff, Tuya, you can download its original software before you overwrite it with any custom firmware. You can download it by checking that box here. You also need to pick the size of flash memory in that product. Why you may need it? Downloading a factory firmware will allow you basically to restore it if you have such a need in the future. In the case of my device, this one, I don't have any firmware in it, so I will skip it. I also suggest checking the box, this box, erase before flashing. It will clean the flash memory before uploading the firmware. I highly recommend selecting it because it will remove all the garbage data in the hardware's memory. If it is not cleaned, sometimes you may experience the instability of a device while it's in operating mode. That checkbox here, self-resetting device, reboots the device after uploading firmware, but this option works only with modules like Node MCU. I don't use it, so it's unchecked in my case. Okay, let's start the firmware upload. I'm gonna press the Tasmatize button. If everything is well connected, the upload should kick off. Alright, as you can see, there's a progress bar here that is moving. The flash memory is being cleaned right now, and once completed, firmware upload should follow. It will take a while. At this point, it looks that the upload has been successfully completed. I will disconnect device from the USB port now, but before that, let me show you the ESP LED. AFE firmware has a pre-configured LED on GPIO2, and if your device has built-in LED on GPIO2 too, you can observe light signals through the first launch of AFE firmware. During the first launch, a device needs a bit more time to start operating. It formats the flash memory, which takes a few seconds, while formatting LED indicates it with stable, constant light, like you can see now. Once LED starts flashing, it creates database to store configuration and prepares a default configuration as well. When it flashes more or less twice per second like now, it's ready for the initial configuration. To make the first configuration, you shall connect to Wi-Fi network called AFE device. And once you are connected, in the internet browser, please enter the following address: 192.168.5.1, and after a few seconds you should see the AFE firmware Wi-Fi configuration site. But you can learn how to configure AFE firmware in my next video. In this one, the upload process has gone quite smoothly, but of course there can be problems. If you experience such, I will invite you to join SmartNIDOM forum. Many experts out there will help you not only with AFE firmware, but also with other firmwares for devices based on ESP microcontrollers. If the video helped you, was useful, let me know by thumb up. I also encourage you to subscribe to the channel, especially if the topics of smart homes are interesting to you.